Welcome all. Today we will look into the projection of solids where the solids are inclined to both HP and VP. Solids are inclined to both HP and VP. Today we can solve one problem related to the projection of solids inclined to both HP and VP. We have already discussed the projection of solids which is inclined to only one reference plane, either HP or the VP. We have discussed both cases separately, and now we will look into the projection of solids inclined to both HP and VP. Here is the problem. A square pyramid 40 mm base side and axis 60 mm long has a triangular face on the ground, and the vertical plane containing the axis makes an angle of 45 degrees with VP. Draw its projections. Take apex near to VP. Okay, here square pyramid have a 40 mm base side and axis 60 mm long, so that we can draw the base figure in such a way that here the condition is the square pyramid resting on a triangular face on the ground. That means that the triangular face resting on HP. That means the base figure. In the base figure, the axis must be perpendicular to HP or perpendicular to that ground. We can treat that ground as HP, horizontal plane. Then if the given condition is the axis inclined to HP, or the triangular face or the slant heights in HP, means in its base figure, in its first pair of the projection, the axis must be perpendicular to HP. Here we can treat that ground as HP, ground as horizontal plane. Then we can draw the first figure or the base figure like this. First we have to draw the XY line, then we can draw the top view of the square pyramid. Here, if the pyramid is like this, then in top view we can see the slant heights. And similarly we can see the shape of the base is nothing but a square. Then here we can draw the first figure like this. That means the first square figure is like this. Then we can draw the slant heights. When the pyramid is resting on HP, this is HP. Then the pyramid is resting on HP. Then in its top view, we can see the slant heights. If the entire base is on HP, we can easily see the slant heights in top view. Then we can mark that slant height in top view and name it as AO, BO, CO, and DO, slant heights. Then we can project that entire points into the XY line, and we can name it as B dash in bracket A dash. We have already discussed this in nomenclature, because in front view B visible, A invisible, so that A dash, front view of A, must be in bracket. Here C visible and D invisible, so that D dash must be in bracket. Then we can represent the axis. Here axis height is equal to 60 mm. We can draw the axis like this. Then we can name it as O dash P dash, and then we can complete the O dash P dash, and we can complete the front view. Like this. Then we know that actually this triangular face CDO, triangular face CDO, this particular triangular face CDO is represented as a straight line in front view. Is represented as a straight line in front view. That means C dash, D dash, O dash. That straight line will become the front view of this particular triangular face. Then if we rotate this particular figure, particular front view, and draw the same front view in such a way that one of its triangular face, that means here that triangular face is C dash, D dash, O dash, and that straight line is in XY line. Is in XY line means automatically that triangular face is in HP condition satisfied. Automatically the triangular face in HP condition satisfied. For that purpose, we have to select the first base figure is like this. Otherwise, we can select that square shape like this also. If we select this particular figure as base figure, then after rotating the front view, we will get this particular straight line in XY line. That means this particular straight line means here this is ABCDO. Then this CO, slant height CO, will become this C dash O dash. That means if we rotate this particular front view and make that this straight line C dash O dash in XY line, then that condition will become the slant height on HP, slant height CO, slant height on HP condition. Here we need actually the triangular face on HP condition, so that we must select the base figure like this. Then we can rotate and make this this triangular face in HP condition fully satisfied. Then here O dash, C dash, D dash, this triangular face is in HP condition satisfied. Then we can measure this angle theta, and we can draw or transfer the theta here, and we can complete this base, the length of base. We can transfer this length from first figure to second figure, and we can make it this point as P1 dash, mark this point as P1 dash. Then P1 dash O1 dash will become the axis. Then we can complete this triangle. Same triangle, but this triangular face is in HP condition satisfied in the second figure. Then we can project that entire points, and we can locate A1 here, because the projection line which is passing through A1 dash and the horizontal line which is passing through A will meet at this particular point, and that point will become A1. Similarly, this point will become B1, this point will become C1, and this point will become D1. And the projection line which is passing through P1 dash and the horizontal line which is drawn from P will meet at this particular point, and that point will become P1, and this point will become O1, and we found out all the points or corners and apex also. Then in the first step, to complete this top view, we can draw in first step we can draw all the outermost edges in thick line. All the outermost edges of the solid is always thick line. That means this portion is always thick line. Then we can draw the visual rays. This in top view means this visual rays will touch A, B, C, D, all corners, all points. That means this entire base is visible. So that A1, B1, C1, D1 must be in thick line. That means entire base is visible. That condition satisfied. Then again, in top view, we can't see C1 dash O1 dash. That slant height is not visible. Similarly, D1 dash O1 dash slant height. That slant height also not visible in the top view because this visual rays can't touch that line. That means that slant heights are not visible. Then we can draw that slant height as broken line in top view. Then finally, the axis is always chain line. Axis is always chain line. This is the secondary condition. Then in the third step, here the first condition, the axis inclined to HP, condition satisfied. Because this axis, if that axis is perpendicular to HP, then automatically that axis is parallel to VP. Here the same condition is here also, that that axis is parallel to VP. Here that axis is parallel to VP. While examining this particular top view, we can see that P101 is parallel to XY line. Plan parallel to XY line means that in that front view is parallel to VP. That front view or that object's axis is parallel to VP. Then the second condition. In the second condition is that the vertical plane containing the axis, makes an angle of 45 degree with VP. That is the condition. Here, the vertical plane means in top view we can see that vertical plane as a straight line. Then the vertical plane containing the axis means here that P101, this straight line. Actually, this straight line is the vertical plane. This straight line is the vertical plane containing axis, and that straight line, that vertical plane must be inclined 45 degree with VP. That means we can rotate this entire figure like this. Here this angle will become 45 degree, and that is not the true inclination with VP. But actually this is beta, apparent inclination with VP. That means true length will represent true inclination with VP. But here P101, actually the P101 means the top view of the axis. That top view of the axis is not in true length. Actually, the true length of this axis is P1-O1. P1-O1 is in true length. But this top view P1-O1 is not in true length, so that top view, the angle made by the top view is always the apparent inclination in the case of line inclined to both HP and VP, or in this particular case. Then this angle will become beta, and that's equal to 45 degree. We can tilt this figure like this. Here, for this purpose, we can draw first a straight line like this, Then we can locate a P2 on that particular line, and we can represent P2O2. Here P1O1 is equal to P2O2. We can represent that length. Then we can draw or locate this particular point, which is at a distance, this small distance along that straight line. Then we can draw a line which is perpendicular to axis passing through that point. A line which is perpendicular to that axis. A line perpendicular to axis which is passing through that particular point. Then we can draw this straight line, which is perpendicular to axis. Then we can transfer this distance, this distance here. Then we can locate A2, B2. Similarly, we can transfer this distance also, this small distance in the other side here. Then we can draw a perpendicular line like this. Then we can locate D2, C2 also. Then we can draw the dark shade lines like this. If we can locate A2, B2, C2, A2, B2, C2, D2, then we can locate this if we can locate this all these points, we can connect all the points and we can draw this particular figure like this. Then after completing this top view, we can project the entire points like this, and we can locate first A1, the meeting point of the projection line which is passing through A2 and this A1 dash. We can locate that point as A2 dash, then we can locate B2 dash here, then we can locate C2 dash here, C2 dash, this point is C2 dash, then we can look at D2 dash here, then we can look at O2 dash here, then in the next step, again we can draw all the outermost edges, in thick line. Draw all the outermost edges in thick line. Then in front view, after drawing this visual rays, we can see that in front view, edge C2, D2 visible, then edge C2, B2 visible, This edge is visible in front view, C2, B2. Then that edge must be in thick line. C2 dash, B2 dash must be in thick line. That means in front view, this entire base is visible. That is why all the edges will become thick line. For this purpose, in the first case, we can't check with this visual rays, but we can draw all the outermost edges as thick line. There is no checking is needed. We can draw all the outermost edges in thick line. Then after that, we can check with this visual rays. Then finally, we can draw this slant height A2, O2 is not visible in front view, or this visual rays can't touch that slant height, so that we can represent that edge broken line, in broken line. We can represent that edge in broken line. And finally, the axis P2 dash O2 dash in chain line. P2 dash O2 dash in chain line. This is the final figure. This is the final front view, final figure. This is the orthographic projection of the this particular problem. The most important thing is that the apex is nearer to VP. We can rotate this figure in other direction also. Here apex is nearer to VP. Here apex is nearer to VP. Or otherwise we can rotate like this. Then the apex is away from VP. Then we can also draw the front view corresponding to this particular top view. In the next problem, we can discuss that one also in another class. Here, actually, this 3 pairs are needed for this particular problem. The apex is nearer to VP means this apex must be nearer to VP. Apex O2 must be nearer to XY line. Here, apex is away from VP. That's all for now. Thank you. Thank you all.